All right, so we are going to be talking about our second conic section today. First was circles in section 1.9. Now we're jumping to section 9.1 with the ellipse. So a circle, by definition, is the set of all points that are equidistant from one fixed point. So the center being the fixed point, and the equidistant, the distance being set as the radius. An ellipse is also the set of all points, but it's whose distances from two fixed points is constant. So every point on an ellipse that you see is equidistant from the sum of those distances is equal when I look at the two F1 and F2. We call the fixed points foci. I have also heard it said foci, so either way. Individual ones are called the focus, so this is the plural. The midpoint of the segment that connects the foci is the center of the ellipse. So just like a circle has a center at HK, so does an ellipse. And you can see the general form of those equations here. So standard form has the H and the K, tells us where the center is. And general form is where we just have everything kind of all thrown together. Standard form is the form that we need to be in order to actually graph. So just like we did with the circles, we're going to sometimes have to convert from general form to standard form using our completing the square skills. Formulas, again, like I mentioned with the circles, are given to you for the final exam. This is on the formula sheet. So this is exactly what you're going to have access to. So it tells whether it's vertical or horizontal. It tells where the center is. It gives you the formula for C because it tells you here that C is the distance from the center to a focus, and that could be to either of them. So I've taken some of those formulas and put them on here. I also wrote the formulas. These are not on the formula sheet, but just most people kind of know this intuitively. But if your center is at 0, 0, then that means because H and K are both 0, that you end up with something that looks like this, where you don't have that H and that K. So C is the length between the center and the focus, and we find that distance by using the A and the B that come from the denominators of our standard form. Now, how you know which way is which is, in this case, we always put A under the variable that tells the direction the ellipse goes. So here, A is under the X, which means that the X is the major axis, which means that this would be a horizontal ellipse. This is a vertical ellipse because A goes underneath the Y's, which means it goes up and down. The way you tell the difference is because A is bigger than B, always, on an ellipse. So you look at the denominators, whichever one is bigger, you say, okay, that's my A squared. That allows you to find your A and B values. So if we're looking at the key parts of an ellipse and labeling them, the center is always at HK. So this is my horizontal ellipse. Just like this guy is my horizontal formula. So wherever your center is, these are the foci. And we know that C is the length between the center and a focus. So if I'm moving to the right, that means that I'm adding C. So X value plus C, they're going to have the same Y value because they lie on a vertical line. This one would be H minus C. Okay. Now, these are what we call the vertices and the co-vertices. So the vertices are always going to be on the major axis, and the distance from the center is going to be A. So again, we know that the y-coordinate has to stay the same because they're on the same horizontal line, but this is going to be whatever my center coordinate is, H, and then plus the A value. So then likewise, this would be H minus the A value, and that would be K. The co-vertices are on the minor axis. So the minor axis is the shorter one. That's why we knew this was horizontal, because the horizontal axis is longer. So it's going to have the same x coordinate as the center, but then it's going to go b units up and b units down. Now, when we have a vertical ellipse, it's really all the same idea. We know that the length of the major and minor axes are 2a and 2b, which means that the vertices are a units from the center, the co-vertices are b units from the center. So we're really doing the same thing, but it looks different because we're on a different axis. So this is still my HK. In this case, my horizontal axis is the minor axis, which means b units from the center. So H plus B with the same Y, and H minus B with the same Y. My vertices are A units away. In this case, A units up and down, so they have the same X coordinate. But then I'm going to go K plus A, and down here, K minus A. The foci, same idea, except they're C units away instead of A units away. So we would be adding and subtracting the C value for those foci. So that kind of gives you an idea of our key features. This is the formula we need to find C when we have our A and B. So let's look at what you need to be able to do. And I've tried to pick a variety here, but I've tried to pick more of the difficult ones so that hopefully if you have seen me walk through the more difficult ones, then the ones in your homework that aren't this difficult will hopefully seem like a breeze. So here we're supposed to find the center, vertices, and foci of the ellipse, and then we're going to graph it. So just like we did in the circles, we are going to have to complete the square. So I need to gather my terms. So I'm going to gather my x's together, gather my y's together, and move my constant over to the right. In this case, my x has an a value in front, so I know I'm going to need to factor that out. So then this gives me plus 6x. My blank will go in the inside. My y does not have a value in front of it, so I do not need to factor anything out of there. Just add my blank for the y, and then 2 blanks on the right side. So 6 divided by 2 is 3. 3 squared is 9. I do have to do the swoopy multiply thing here for my blank on the right. Then this one, negative 2 divided by 2 is negative 1. Squared is 1. I do not have to swoopy multiply. Those ones should match. So then factor my PSTs. This gives me x plus 3 squared and y minus 1 squared. When I combine my like terms over here, I get 16. Now, when we look at what I have here in comparison to what I want, if I look over here at my conic formulas for an ellipse, I need it to be equal to 1 on the right side. So whenever we've completed the square, I then need to divide the entire equation by whatever is on the right, if it's not 1, which in this case it's not. So divide everything by 16. So that is going to produce fractions, but that's what I want. That's how my formulas look. So the 4 goes into 16 4 times. So I end up with x plus 3 squared over 4 plus y minus 1 squared over 16, because nothing canceled here, equals 1. So in order to find all my key features, I need to make sure I know which type of ellipse it is. Notice on the formulas, the x always comes first, the y always comes second, but A is bigger than B. So I'm just looking to see which number on the bottom is bigger. That tells me which type of ellipse it is. 16 is bigger than 4, so that means y has the bigger value, which means, okay, that tells me that A squared is 16, B squared is 4. So that also tells me that this is a vertical ellipse because y has the bigger value, so that means y's go up and down. So it's a vertical ellipse. I also know that A has to be 4 and B has to be 2. In order to find all of my key features, I'm also going to need my C value. So remember that C squared equals A squared minus B squared. Again, that formula, it's on these notes, but it's also right on here in your formula sheet for the exam. So I'm going to plug things in, and my A squared is 16. My B squared is 4. And so that gives me C squared equals 12. And so I then have C equals the square root of 12, which simplifies because 12 is 4 times 3. So we would write C as 2 radical 3. That'll be important. We'll need that both for the graphing and for listing our key features. So it's totally up to you whether you find it easier to list the key features first and then graph, or graph and then list the key features. That doesn't really matter. So in this case, I'm gonna maybe do one of each. So this time I'm gonna look at the equation to get all my key features and then graph it. So my center is at HK, so I look at my standard form here, and I've got negative 3, 1. So negative 3, 1 is my center. My vertices are going up and down because I know that this is a vertical ellipse. So they go A units up and A units down from the center. So up is the y coordinate, so the x coordinate is going to stay the same. So I'm going to go 1 plus 4, which is 5. And then my other vertice, I'm going to go 1 minus 4, which is negative 3. It did not ask me to find the co-vertices, which are B units, in this case left and right, so you don't have to list those, but we'll need them when we graph. The foci, it did ask me for. The foci, you'll notice on the pictures we drew on the front of the notes, are always on the major axis. So they're always going the same direction as your vertices are. So in this case, up and down. So I'm going to have the same x coordinate as the center, but then I'm going to go up and down 2 radical 3. Now here, I didn't list them separately because I'm not going to be able to simplify. It's going to stay 1 plus 2 radical 3 and 1 minus 2 radical 3, so might as well save ourselves some writing. You can list them separately if you want, but if they're not like terms, you don't need to. These ones we need to because you're not just going to write 1 plus or minus 4 because both of those things simplify. So these are all my key features. And I need to draw then the graph. So, excuse my kindergarten handwriting. That is hard to avoid. All right, so we've got our center at -3, 1. And then I know I'm going to need to go 4 units up and down. My B value is 2, so I need to be able to go at least 2 units left and right. So I think this should give me plenty of space. If you have graph paper for your homework, that might be helpful. Okay, so I've got my coordinate plane. Now I'm going to go ahead and graph it. So -3, 1 goes here. There's my center. My vertices, -3, 1, 2, 3, 4, 5, and -3, -3. Remember, the co-vertices are going to be B units left and right in this case. So 2 units right and 2 units left. Those are my co-vertices. I would suggest when you draw an ellipse, trying to make it 2 like parabolas. If you try to draw the whole ellipse at one time, usually doesn't work out super well. So there is my ellipse. It didn't ask me to graph the foci, but if I did, I would use my calculator to figure out how much 2 radical 3 is and go up and down from the center there. All right, example 1b, same idea, but different type of equations. So I'm going to gather my x's together, so grouped them, group my y's, move my constant over to the right. Now this time, both my x's and y's have that a value in front that needs factored out. So factor it out of both terms. Add my blank on the inside. Here, factor the 9 out. Leave a blank on the inside. And then we have that equal to 11, and then we've got our 2 blanks. So completing the square, 4 divided by 2 is 2, 2 squared is 4, and then you have to swoopy multiply. So 16 on the right side. -2 divided by 2 is -1, squared is 1. Swoopy multiply again, that gives me 9 for my blank for the right side. So then I'm going to factor my PSTs. So I've got 4 times x plus 2 squared plus 9 times y minus 1 squared. And then 11 plus 9 is 20, plus 16 gives me 36. Like I said in example 1a, I need it to be equal to 1. So because I have 36 over on the right side right now, that means I'm going to divide the entire equation by 36. That will also produce my fractions. So x plus 2 squared, 4 goes into 36 9 times, so 9 would be my denominator here. Then y minus 1 squared, here I get 4 in the denominator, and then equals 1. So in this case, I can see 9 is bigger than 4, which means that my a squared is 9, my b squared is 4. So that tells me a is 3, b is 2. This also tells me that this is a horizontal ellipse because the bigger number is under the x. So this time I'm going to graph it first before I write out everything, because I told you it does not matter which way you do that. So draw myself some axes here. Sure, I spaced those evenly, but that's okay. And so when I go to graph it, I look here, I would see my center should be at -2, 1. So plot the center. Then my A units, because it's a horizontal ellipse, that means I should be going that many units left and right. So 3 units to the right, 1, 2, 3, and 3 units to the left, 1, 2, 3. From the center, B units up and down to get the co-vertices. So 2 up, 2 down, and then like I said, connect them like it's 2 parabolas. So I've got my ellipse graphed. Now I just need to write out what I have graphed there. So my center, I can see here is at -2, 1. My vertices, I can look and list. So that's -1, 2, 3, 4, 5. So -5, 1, and 1, 1. My foci, I'm going to have to do work for. So c squared equals a squared, which was 9, minus b squared, which was 4. So c squared is 5, which means c is the square root of 5. And that doesn't simplify further. So this time, my foci are going to be on the horizontal axis, because that's the major axis this time. So my foci are going to go left and right of the center. So that means I'm going to use the x coordinate of the center, -2, and then plus and minus the radical 5, because that's the c distance. The foci, because they'll be on this axis, should have the same y coordinate as my vertices and center. So got my key features, got my graph, and I'm finished. All right, example 2 asks us to find the standard form of the equation for an ellipse that's centered at the origin with a horizontal major axis of 16 units and a minor axis of 10 units. So here, if you look at what it says about the major and minor axes in our notes, it says the major axes and minor axes have lengths 2a and 2b. So when they give us those lengths, they're trying to give us the a and the b values. So that means major axis of 16 units, that tells me 2a, because a is on the major axis, equals 16. So a is 8. Then it tells me my minor axis is 10 units. That tells me 2b equals 10. So b is 5. This has also told us that it's centered at the origin. So that means h and k are both 0. And it tells us that our major axis is horizontal. So that means that my a squared is going to need to go underneath the x's. So because I'm centered at the origin, that means I'm going to be using these formats. In this case, the first one, because my a squared should go underneath the x. So it's plain x squared and plain y squared that I'm going to be writing here. So if b is 5, that means b squared is 25. If a is 8, that means a squared is 64. So when I go to write my equation, then I know I'm going to have x squared first with 64 underneath because it's major, plus a plain y squared with the b squared underneath, which is 25, and I know it needs to equal 1. And so that one's pretty short and sweet. We've got our equation, and that's all it asked us for. All right, last example, write the standard form equation of an ellipse whose vertices are at 7, -2, and -3, -2, and whose foci are 4, -2, and 0, -2. Now, this is totally up to you how you want to do this. Some people prefer to just look at the numbers Other people prefer to graph it so that they can visualize it. Whatever works best for you is fine. I personally am not a visual person. The formulas are generally what I like to use better. So all I'm going to do when I'm looking at this, first of all, when I see that the vertices have the same y coordinate, that tells me that I'm going to have a horizontal ellipse. So same y coordinate means a horizontal line, which means it's a horizontal ellipse. So that means that my major axis goes left to right. So the other thing that this tells me when I look at the x coordinates is the distance between those vertices is the length of the major axis. So distance between is the length of the major axis. So in this case, from 7 to -3 is 10 units. So that means 2a equals 10, which means a is 5, which means a squared is 25. So that helps us. So I've gotten a lot of information so far. I know what type of ellipse it is. I know my a and a squared values. Now I look at the second piece of given information, which are the foci. I should already know that it's horizontal, so the y coordinates don't give me a lot here. But the distance between the two foci is going to help me find my c. So distance between foci so that's 2c. So the distance from 4 to 0 is 4. So that means 2c equals 4. So c equals 2. Oops, I'm jumping ahead to c squared. C equals 2, which means c squared equals 4. Now, in order to write my equation, I need to know where my center is, and I need to know what my a squared and b squared are. The center is pretty easy. I can find that by either finding the middle of the two vertices or the middle of the two foci, because the center is always halfway between the two foci. It's always halfway between the two vertices. In this case, I'm going to use this one because the numbers are smaller. Center is midpoint. Of these two. So that means that my center in this case is going to be at 2, -2, because 2 is halfway between 0 and 4. You could also use, your A or your C values that way as well. So I know where my center is. So now really all I need is my B squared because I've got A squared. I also have C squared. So that means I should be able to solve for B squared. So C squared equals A squared minus B squared, we know. So plug in C squared, that's 4. Plug in A squared, that's 25, minus B squared. So in this case, subtract the 25. That gives me -21 equals -b squared. So b squared is 21. We don't need b, we only need b squared. So I know it's a horizontal ellipse. I know that my center is here, so x minus 2, putting in my h. This is my h, this is my k. So x minus h squared over, because it's horizontal, I'm going to put it over a squared, so 25 plus, then my k value is -2, so this would be y plus 2 squared over b squared, which we just said is 21, and that should be equal to 1, always on an ellipse. So there is my standard form equation, and that wraps up our examples for ellipse.